All right, CNT125, Chapter 8. We're now moving back into subnets. So remember a single LAN. If all these computers are connected together with switches, and all these switches connect to one router, we have one giant broadcast domain, one giant LAN. So if this is floor 1, floor 2, floor 3, all this traffic from all these floors is getting mixed together into one giant network. It's one giant broadcast domain. So as this computer boots up and asks for an address, all the computers here would see that. With a subnet, as my network grows like that, with a subnet, I would need to start breaking this apart, maybe by floor, a switch on each floor, and then connect it to a router. The router now can allocate or take this one big network and break into pieces. Subnet here, different subnet here, different subnet here, and now each of these are a smaller network of the whole. And the router is keeping their traffic kind of contained to their floor now. That is kind of the beginning of starting to segment our network. I do a subnet per floor. Now, that may or may not be too feasible. A lot of routers don't have a lot of ports in them. So just as a little note, that might not be feasible, but we'll get to that down the road. So as my network grows, this right here, again, this router is trying to create that broadcast boundary for me. A broadcast domain here, broadcast domain here, broadcast domain here, subnet here, subnet here, subnet here. That's what it's starting to do for us. So subnets help us take this big IP address space, manage it, and maybe even break into pieces so I can allocate a piece to each part of my network. In this case, maybe each floor of my network. Subnets are going to provide the following benefits. It's actually going to help with network documentation. I can say this subnet for this floor, this subnet for this building, this subnet for this type, these IP phones here, this subnet for these wireless users here. It's also, because I'm doing that, it's going to make it easier to locate problems. If I'm getting a lot of errors from certain chunk of IP addresses, I know it's a certain subnet, I know it's the wireless users then. Routers can more easily manage IP address spaces that don't overlap now. It can say this subnet is allowed to do this subnet over here is not allowed to do this. This subnet can get to the internet and check email, this subnet here cannot, it can only browse to the internet. And this also helps make routing a larger network. Routing is more efficient with a larger network. They're mathematically related at the binary level. It can process that a little bit quicker, if you will. So with that, we need to start reminding ourselves again about subnet masks. Okay, the subnet mask is letting us know what part of the address is network, what part is the host, and it's also doing that, from your host moving into the network. That subnet mask, it starts knowing it's on this network or this network. It's in the network I'm on, or it's some other network by looking at that subnet mask. The PC, when it's getting ready to send data, will look at the destination. The network ID of the destination host, and if it's on the same network, it knows, oh, it's on the same network. The switch should process it. I'll send it locally, if you will. If it's on a different network, if it looks at it and go, oh, that's a different network than mine, then it knows to forward it to the gateway address, default gateway address, which most likely is the router that will route me out of my network or out to the internet and get it to that, hopefully that network over there, wherever it happens to be. And that's what my host or my node's doing by looking at that subnet mask. The subnet mask lets us know what part of the address is network, what part is host, what part of the address is network and subnet potentially, and which part is host. And remember, ones are indicating network and subnet. 0 is representing host. So here's ones representing network portion. This octet over here, all zeros representing host portion. So we would now know, looking at this address, these 3 octets up here, 192.168.123 is the network piece. The 132 is the host piece. That's what that starts telling us. And hopefully we remember our default subnet masks from earlier. Class A default subnet mask 255.0.0.0. Class B 255.255.0.0. Class C 255.255.255.0. Remembering network portion here, network portion here, network portion here for A, B, and C. So as I start looking at some examples, we'll start seeing what the subnet mask starts telling us. If I see a host address of 92.15, 95 tells us class A, we should be thinking network host host host. We should be thinking 255.0.0.0 for the subnet mask. But if the subnet mask is 255.224, we know subnetting has occurred. Or my workstation knows that subnetting has occurred, and it would look at that to go, am I on the same subnet as this thing or not? If I see a 135 address, we know it's a class B. So we're thinking network network. Last two octets are host host. We're thinking 255.255.0.0. But if the subnet mask is 255.255.240, we know subnetting has occurred. Not quite sure how yet, but we know it has occurred. If I look at a address like 195.15.32, 195 tells us the class C, so we're thinking the first three octets are network, last is host. We're thinking 255.255.255.0 because first three octets are network, last is host. If we see a subnet mask that's 255.255.255.192, we know some kind of subnetting has occurred. So recognize that. Recognize when you look at that first octet and look at the subnet mask, try to know, oh, that's the default, nothing has occurred, or that is not the default, it's different. Something has occurred, some kind of subnetting has occurred. Not sure yet, but we know some type of subnetting has occurred. That's the kind of thing that your workstations are doing. Now, that leads us to ANDing. I'm going to throw this out here because we'll need this later on. ANDing is a logic function that routers will use to determine if something is on, or actually what network something needs to be routed to. Let's put it that way. So when a router gets a IP packet, it takes that destination IP and subnet mask and it ANDs them together to find out what the network ID is, what the network is or the subnet is that it needs to route this traffic. And it's a logic function. ANDing is a logic function. Logic as in electronic logic gate. So a 1 bit and a 1 bit ANDed together will yield a 1. Anything else is going to be 0. A 1 and a 0 is going to be 0, a 0 and a 1 is going to be 0, 0 and 0 is going to be 0. So you can almost think of it like multiplication. I do 1 and 1 is going to get 1. Any other thing is going to be 0. So when the router ANDs that IP and subnet mask, the result is it gets the network and or the subnet number if subnetting occurred. And now it knows that network or subnet number and knows to look it up in its routing table and try to find out where to route it to. We'll talk about the routing in Chapter 9. So I have an example here, node A address, node B address, ANDing. Same network is going to send directly, different network is going to send it to the default gateway. So if we have a node A address, 172.16.31.250/20, here is the IP address of that, and then here is the subnet mask of that. The /20 is your 20 bits, 16 plus 4 more here for the subnet mask. There's your 20 bits. So as it ANDs these together, 172 is going to get ANDed through and be 172. 16 is going to get ANDed through because all the ones, and it's going to be 16. 31 is going to get ANDed with this right here. And I'm going to get 0, 0, 0, 0. And then I'm going to get 1. And then 0, 0, 0. So it ends up with a 16 here. Yeah, this address belongs to the 16 subnet, the 172.16.16.0 subnet. So now the router would know to look that up in the routing table and to route it to that network. And here's the node B address. That's in the 32 network. So those would be on 2 different networks. And it would know that to know to route them to 2 different networks. That's what the ANDing is all about. So yeah, this is 2 different networks. It knows it'll need to use the default gateway of the router to be able to route that traffic to its destination. Keep ANDing in the back of your brain. We're going to use that for some quick checks on things, and then we'll show you some other shortcuts. We also want to remember CIDR notation. We'll talk about CIDR in detail later, but just initially, classless interdomain routing, we can use a /count for our subnet mask, right here, /24. That'll let us know that 24 bits are being used for the network and subnet portion of the address. That's what that's telling us. So if I have a class A 255000, that'd be a /8, because there's 8 bits here making up the subnet mask. So again, if I have a 951532, 95 tells us class A, 255000, that's what we see for subnet mask for decimal. A /8 is going to represent the same thing. There's 8 bits here making up the subnet mask. If I see a /12, then I know some subnetting has occurred, and it's these 4 bits here. These 4 bits right here are the subnet piece now. And I now see a 255.240.00. So that 240 lets us know something occurred, or this /12, because it's supposed to be 8. We now see 12. There's 4 bits in there being used for subnetting. If I look at a 135 tells us class B, I'm thinking 255.255.00. Here is that written out in binary, 255.255.00. Well, the 255.255 here, that's 16 bits. So that default is a /16 for class B. If I see a /20, I know that, again, 4 more bits got borrowed for subnet. There they are right there. So I would know subnetting has occurred because it was more bits than 16. I see 4 more. I know 4 bits got borrowed for subnetting. If I have a class C, or I have a 195, 195, I know it's a class C 255.255.255.0. This right here, written in binary, is going to be this right here. That's our 24 ones. There's 24 ones there making up that number. 24 ones followed by 8 zeros. So a /24 is my default subnet mask for class C, /24. So if I see a /28, again, I know 4 bits got borrowed for subnetting because I have the 24 plus these 4 more right here. So that subnet mask /28 lets us know subnetting has occurred. Okay. Make sure you review your subnet mask, and now in this case your CIDR notation. That's kind of a shorthand we use a lot of times for representing the subnet mask for a particular network. All right, we'll continue in the next podcast.